Here we have a system of linear equations. We notice that both equations have an x and a y, so we will be solving for both of those variables. And in fact, the solution to this system of equations will be the point where these two lines intersect if we were to graph these lines, or graph these equations. We notice that both equations are in standard form, where we have the x's and y's on the same side of the equal sign. In fact, the x's are lined up and the y's are lined up. So that's a clue that the easiest way to solve this system of equations is with elimination. Now, if we were to add these equations together right now, we would end up with 8 x's, 2 y's, and then some constants. That wouldn't do any good because we didn't eliminate either the x's or the y's. Now it's hard to turn a 3 into a 5 to get these x's to match. So let's take a look at the y's. We notice that we can turn this 2 into a 4 pretty easily. So we are going to multiply both sides of this second equation by 2. We'll need to distribute the 2 on the left side. So I've rewritten the second equation as 10x minus 4y equals 32. It's the same equation, it just looks different. Now, let's see, I'm going to take this first equation and write it underneath this second equation that I rewrote. So I'm just rewriting the first equation right now. And we notice when we do that the y's are exact opposites. And that's why we multiplied the second equation by 2. Is so that the y's would be exact opposites. Now that's going to help us because when we add these two equations together, we get 13x. The y's cancel, and that will equal 39. We'll divide both sides by 13, and we get x equals 3. We're half done here. We also need to solve for y. So I'm going to take this 3 and substitute it into either one of these equations for x. Now looking over these two equations, the first one looks like it will be easier to work with than the second one. So I'm going to substitute 3 in for this x in the first equation. So I'm just rewriting the first equation, but instead of x, I'm going to substitute a 3. Now remember, 3x really means 3 times x. So I have 3 times x, which is 3, plus 4y equals 7. Now I just have one variable in this equation, so we're solving for y. So I multiplied 3 times 3. Now I want to keep these y's on the left side and move all the constants over to the right side. After subtracting 9 on both sides, I end up with 4y equals negative 2. Now I will divide both sides by 4. And we get y equals negative 2/4. We can simplify that though. We can divide the top and bottom by 2. That's really negative 1/2. We'll put both parts of our answer together. The easiest way to do that is to write it as a point. Just make sure you remember to put the x first and the y second. So the solution to our system of equations is the point 3, negative 1/2. We can do a quick mental check to make sure that works. 3 times 3 is 9, plus 4 times negative 1/2 would be negative 2, so it checks out in the first one. 5 times 3 is 15, minus 2 times negative 1/2, which would be plus 1. So that checks out also. I hope this tutorial has been helpful. This is Mr. Ela, signing off.